Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems, and I have already done the videos on Module 1 and Module 2 which is related to Network Analysis, and it is already uploaded in my channel. Please do check if you have not checked yet. In Module 3, I have already started with some of the topics. Today we are going to see a new topic in Module 3. I have already done the introduction, types of control systems and effects of the feedback systems. Today in this video, I am going to deal with modeling of mechanical system elements. Modeling of mechanical system elements. Most control systems contain mechanical as well as electrical components. In control systems, we have both mechanical as well as electrical components, right? Electrical components like inductor, capacitor, voltage source and all. And in case of control systems like spring, mass, dashboard, like that, there are some things which are present mechanical as well. In fact, we can show that given an electrical device, there is usually an analogous mechanical counterpart mathematically and vice versa. Here, we can do that analogous is nothing but similar. So, mechanical counterpart. So, electrical has an analogous mechanical counterpart. In fact, we can show that given an electrical device, if there is an electrical device given, there is usually an analogous mechanical counterpart mathematically and vice versa. So, we can write the electrical device system into mechanical and mechanical to electrical device. What does sentence mean? The motion of mechanical elements can be described in various dimensions as translational, rotational or combinations of both. See, translational is nothing but it is in the form of linear action. It contains the what there is no rotation or something, angle is not there. Translational are nothing but linear. Rotational is nothing but rotating in the form of angles, rotational systems, or combinations of both can also be there. We'll see separately in the next slides, in upcoming slides. Translational systems. What are translational? That is, mechanical translational systems are those in which the motion takes place along a straight line. Linear is nothing but what? Straight line. It takes place in a straight line. They are telling that which the motion takes place in a straight line or linear. The variables that are used to describe the translation motion are what? Acceleration, velocity and displacement. The variables which are required to describe a translational motion. The translation or the straight line motion is acceleration, velocity and displacement. I hope you already know what is acceleration, velocity and displacement. So with that we'll go to the next point. Newton's law of motion for translational systems states that the algebraic sum of forces acting on a rigid body in a given direction is equals to product of mass of the body and its acceleration in the same direction. This law can be expressed as you know, Newton's first law of motion, in which force is equals to mass into acceleration. Force is equals to mass into acceleration. M into, you know that acceleration is what? dv of t by dt. Why? Because dv of t by dt. Why? Because it is velocity. The differentiation of velocity is nothing but acceleration. Acceleration is equals to differentiation of velocity by time, dv by dt. And again, vt is what? d by dt of vt is dx by dt. Vt is dx by dt. Nothing but the displacement. Displacement is nothing but dv by dt. Understanding? Displacement dx by dt is nothing but what? Displacement dx by dt. X is displacement by dt is nothing but velocity. So if you substitute in the v of t place d by dt of x, then you will get d square x of t by dt square. I hope you are understanding. F is equals to mass into acceleration. Okay. See, acceleration is equals to what? dv by dt. Again, v can be written as what? d by, Again, d can be written as what? d by dt into dx by dt. In the place of v, we are writing dx by dt. Why? Because velocity is the displacement of d by dt of displacement. That is nothing but x. d by dt of x. X is the displacement notation, v is the velocity, is acceleration. If you multiply d by dt into d by dt, you will get d square x by dt square. That is what is written here. M into d square x of t by dt square. This is the equation which is used for the translational system. The law is expressed. This equation is very important. Why? Because these are the differential equation. Using this only you are going to solve the the problems. This is the formula. In this way we are going to write for all the components of the system. So this is very important. Try to understand this equation where m denotes the mass of the body and a of t denotes the acceleration. In the direction considered, v of t is the linear velocity of the body, x of t is the displacement of the body. Then there are some translational elements and the corresponding equations of motion. First one we have already seen. See, mass of the element. If there is some block and it is represented by m, this is nothing but mass of the element. Mass of the element, x is the displacement, v is the velocity in the direction, f is the force applied, and this is the reference point. Okay. For this type of diagram, how we can write the equation? F is equals to m into a. A is what? D square. We can write a as dv by dt. Again, v is what? Dx by dt. What I explained in the previous slide. F is equals to m into d square x by dt square. It is for mass. For if it is, there is a component called spring element. For spring element, what? Spring element we represented by k. Understanding? K. So x1 of t is the displacement, v1 of t is the velocity, f of t is the force, x2 of t is the next displacement, v of 2 of t is the second velocity. These are the two velocities. It has two velocities and two displacement. How we can write for the spring element? We can write in such a way that f is equals to k. K into, here as we have to m here it should be k. K into x1 minus x2. With respect to x1, if you are considering x1 minus x2, nothing but k. x1 minus x2 can be written as total x, kx. Okay, then k integration. We can write the displacement in terms of integration also. How? D is equals to, you know that, dx by dt. Again, x you can write, if differentiation go to on the left hand side, it becomes integration. So integration of v dt can be written. So in the same way, x1 minus x2 is written as integration v1 minus v2 dt, that is equals to k integration, totally we will write as v dt. Understanding? So these components are very important. Why? Because these are seen in the sums. These diagrams will be given with combination of these three diagrams. We need to write these equations. Writing these equations and finding the transfer function is important in this module, where they are going to ask these only sums. So you need to know this formulas, how to write the for which block diagram which equation need to be considered. Then for F, damper element, it is called damper element. Damper element is also represented by F or B. We can write F or B. If they have given in the question B, consider that B. If they are given as F, consider it as small f. Then, and it is same like spring element. What we will write? F is equals to F cap small f into V1 minus V2 is equals to Fv. Here, first initially we write for displacement f into x1 minus x2, that is equals to fx. Then we can write for the velocity f into v1 minus v2, that is equals to v. Here we are writing in terms of both velocity terms and displacement terms. How we can represent? We are representing in this equation. The question will be in such a way that, for example, there will be a mass element, there will be a spring element, and there will be a damper element. Like this, they are going to ask the question with the reference point. We need to write the equation for this block diagram or the mechanical translation system. So you need to know how to write the equations. What I am telling, these are very important. So you need to remember and need to understand. For mass, what equation? For spring, what equation can be written? For damper element, what need to be written? Then translational system. Here we'll see as I told, one of the example I'm showing here. This is the spring element, this is the damper element, this is the mass element. The displacement is towards this, force is applied this. As force is applying this side, the displacement also will be in this side. See, we are applying force to this side, means the displacement will also become this side only, no? So they're going to mention this, the arrow marks. For this, we need to write a free body diagram. To get to free body diagram is nothing but without these things, directly writing the directions and representing those names. Free body diagram. So it will be useful for in the solving the sums. So for every in future the sums I'm going to deal with on this, you need to write a free body diagram to the question for every question. So free body diagram is written in such a way that m is represented m, x in place of, in terms of x also we will write, in terms of velocity also we are going to write the equations. So you know that kx, force is applying in this way, then the effect will be in this way. So opposite way. So kx, fx we need to write, and f we need to represent in this way. This is a mechanical network. You can, the mechanical network is nothing but we are going to represent in this way. F, xv, mass, and then the spring element and the damper element. We are going to represent in this way. Mechanical network is not so much important, but we should know how they have written. Main thing, free body diagram need to be written. For this block diagram, how to write the differential equation, we'll see. We know that f, these all are in the opposite direction. As you see, f is in this direction, these are in the opposite direction. So what it means, you need to take minus signs for kx and all. So m, anyway it is in the right hand side only, we need to write. So f minus f into dx by dt. Why it is? Because it is a damper element. It is dx by dt we need to write according to the previous equations what I have shown. And for spring element, minus kx we are going to write, that is equals to m into d square x by dt square. This is the d square x by dt square for the mass equation, differential equation. If you take these two equations on the right hand side, they become plus. So either we can write this, from this we are going to convert into this, like from left hand side to right hand side, changing the minus sign to plus sign. And for the, in the terms of velocity also we can write how f minus dx by dt is what? Velocity. Displacement, differentiation of displacement is velocity, minus k into the way I explained previously, integral v dt is nothing but x, m into dv by dt, as x by dx by dt is what? Velocity. So one differentiation need to be removed. So d by dt of velocity is nothing but the, in terms of velocity we can write, or this minus terms can be shifted to the right hand side. So you will get this equation. So we can write both displacement and in terms of velocity. If there is the translational system, translational mechanical system, the differential equation need to be written in this way for the diagram. This is the one type of question. This is the type of a question they are going to ask in exam also. They are going to give and they are going to write, tell us to write the differential equation for this. In some cases they are going to ask even transfer function. We will see in future, but we should know how to write this equation from the diagram. So I am explaining and stressing so much. Then now we are done with translational systems. Now we will go with the rotational systems. Mechanical rotational systems are those in which the motion is about a fixed axis. Okay, the translational system is in a straight line or a linear, but it is about a fixed axis. The motion is about a fixed axis. Those with motion is about a fixed axis. Newton's law of motion for rotational system states that the algebraic sum of moments or torques about a fixed axis is equal to product of inertia and angular acceleration alpha of t. Alpha of t is nothing but angular acceleration. Understanding? In mechanical system we deal with, in translation system we deal with displacement, velocity and acceleration. Whereas in mechanical system we are going to deal with angular displacement, angular velocity and angular acceleration. Understanding? This is angular displacement, this is angular velocity, this is angular acceleration. In translation system, we denote it by x, displacement, velocity v and acceleration as e. Whereas in mechanical or not mechanical, in rotational system, displacement, angular displacement by theta, omega by angular velocity and alpha for angular acceleration. You need to remember this also. So that in rotational systems it is in terms of torque or the moment. Torque is nothing but, we can even represent by t. Torque is equals to moment of inertia j into alpha of t is nothing but angular acceleration. That can be represented in the same way for force, how we have written in the terms of velocity and displacement. For here also angular acceleration will become d by dt of omega t velocity and d square by dt square of theta of t angular displacement. There we have written d square x of t by dt square. Here we are going to write d square theta of t by dt square. That is only the difference. And here it is j. Why? Because it is moment of inertia. There it is mass. Understanding? Only difference is the differential equation writing form is same, but representation is different. Here is angular velocity, angular displacement, and angular acceleration with the moment of inertia. Their mass into displacement, velocity, and acceleration A. So you need to remember this. So only I am stressing so many times and repeating it. So write and practice, so you will understand what I am telling. If you write them and do and understand, it will be easy for you, and it will be like already you will read by writing this. You make a note from this. It will be good for you. Where theta of t is the angular displacement. As I said, omega of t is angular velocity, alpha of t is the angular acceleration. See, if you want to write the differences, you can make the column like this. How? We can write this is the translational system, this is the rotational system. Translational system is displacement x, velocity and acceleration. Here we will consider as what? Angular displacement, angular velocity and angular acceleration, alpha. And we can, and one more thing, one more difference is what? Here we are going to consider the mass of the element. Here is the moment of inertia, that is J. Okay. So you need to remember these differences and need to write the equations accordingly. You need to write the equations like this accordingly based on the given question. Then rotational system, same for like translational elements, there are also rotational elements and corresponding equation. Same, inertia element, there it is mass element. Inertia element also is represented by in a block with J. So mass element is represented here as an inertial element. Spring element is a torsional spring. Why? Because it is a torsional spring. Why? Because it is a rotational system. Torsional spring. And damper element is damper element itself. Then here we show the direction in terms of the rotation. There it was just like this, no, linear, straight line. But here it is rotational, we need to show. So the T is nothing but what? Torque, and theta is angular displacement and angular velocity. There we represent for the translational displacement, that is x and v, velocity. Here we are writing omega and theta. That is the only difference. You need to observe the differences. Then with the reference point, how we can write T is equals to J du omega by dt in terms of angular velocity. In terms of displacement, we can write as z square theta by dt square. There we have written equation in terms of velocity and displacement. Here we are writing in terms of angular displacement, angular velocity. Okay, the torsional spring element, again the spring is same. We are going to write 2. As there we have to take x1, x2 and v1, v2. Here omega 1, theta 1, omega 2, theta 2, t. So T is equals to k into theta 1 minus theta 2, that is equals to k theta. And in terms of angular velocity, how we will write? Integration omega 1 minus omega 2. Same how it is translational. Rotational is also same, but the notation is different. How you represent, that is omega and v, that is different. Damper element. Damper element is again, you are going to the question will be in this form, rotation form, and same way T is equals to f into omega 1 minus omega 2, that is equals to f omega. F of theta minus theta 2, that is equals to f theta. Understanding? So these two equations, these three equations in rotational and translational system are very important. You need these equations to solve the problems. So keep note of it. Okay, even the units are also given downside. You need to remember them also. These units are also important. So this is the rotational systems. Then rotational system, one of the example we'll see, as we have seen for translational. See, rotational. This is the axis is constant as said by the definition. Shaft to stiffness. This disc is moving with an angle of theta and torque T. Viscous fluid is F. Damper circuit F. Okay. So how we can write here is theta, torque we will write in this way, and theta is the displacement, theta. So if this is this side, the direction of the damper circuit and the spring will be opposite. Keep that in mind. Opposite side only we should take. Okay, here k theta and f into d theta by d theta. Why? Because damper circuit is will write as d theta by dt, and for spring it is k theta. Okay, this is the mechanical network. You just check it out. Then same way how we are written for translational system, we'll write the equation, and you can take on the right hand side. Here I am representing this in terms of omega. See how we have represented t minus f omega minus k into integration omega dt is equals to j d omega by dt in terms of angular velocity. This is in terms of angular displacement, this is in terms of angular velocity. Again, if you take the left hand side on the right hand side to make all plus, the torque equation will be looking like this. That's it. You need to remember this is the main equation. I'm sorry. I'm just writing this or because we can write left hand to right hand side. It is took. So this equation and this equation are very important again. Okay, it is in terms of angular displacement. This is in terms of angular velocity. The equations of rotational systems. If you check, all both equations are same. Only the notation. In place of x it is theta. In place of m it is j. And in place of omega, in place of omega, in place of v it is omega. Here we have took the v, here we are taking as omega. That is the only difference. Understanding? If you compare with that, then you will understand. So by this modeling of mechanical system, basic concepts of the what are the elements of the translational and rotational systems I have told, and equations. So what I'm going to do is I'll complete the electrical systems also next, and analogous systems also. I'll release the videos. After that, I'll solve the problems on this mechanical systems which are related to electrical systems also, and analogous system also. So at a stretch, why? Because you need to understand what is electrical system and analog system to solve the problems on the mechanical systems. So I'll do this 5th and 6th topic video also in the next videos, so that you'll understand. Then we can go to the sums. I'll make a separate video for problems. So till now now in this video I completed modeling of mechanical systems, 4th topic. I'm stopping the video here. With a new video on the topic electrical system, I'll release the next video. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.